So in this video today, we're going to talk about finding the area and perimeter given coordinate points. So we're going to do this for various different shapes, okay? So perimeter, just as a reminder, is the distance around the shape, whereas area is the total space taken up by a flat 2D surface or shape of an object. So when we talk about perimeter with a triangle, we're just going to add the three sides together. With a rectangle, we can do 2 times the length plus 2 times the width. With a square, we can do 4 times the side. Now, if it's whatever agon, like a pentagon or a hexagon or whatever, pentagon's 5 sides, right? So you'd add all 5 sides. Hexagon, same thing, okay? So when we're talking about area, the primary object that we're going to find the area of are triangles, and that's going to be 1/2 base times height, okay? That's what B and H stand for. So, first of all, I don't know why this is down there like that, but we'll scroll up. It says a horse corral in the shape of a pentagon is shown below. The scale of the drawing is 1 unit equals 4 feet. How many feet of fencing would be needed around the area? Round your answer to the nearest foot. So now some of these sides we can count, right? But some we can't. So we're going to use Pythagorean theorem to find the ones we can't. So first of all, I'm going to do this bottom right here. And I notice that's going from -1 to 7. So this is 8 wide, right? Our two vertical sides right here are going to be, you know what, let's do that in a different color. So we're going to go 5 down to 4, right? So 5 plus 4 is 9, right? So both of these sides are going to be 9 because we can tell they're the same height, right? Now what we're going to use to find the two slanted sides, which almost look like a roof here, but that's not what they are. So we're going to do this. We're going to find this length right here. And to do that, we're going to go up 1, 2, 3, and over 1, 2, 3, 4. See that? Up 3 over 4. So this is a right triangle, agreed? So we're going to use 3 squared plus 4 squared, Pythagorean's theorem, and that's going to give us the length of our side, okay, when we take the square root of it. Because remember, this would be a squared plus b squared equals c squared, right? So when we do that, we're going to get 9 plus 16. That's 25. And then what we're going to do with that 25 is take the square root of it. Now, we've been doing this all week, so you guys should see that that's a very familiar process, right? So that means that length right there is 5. Now, let's see if the other side is the same. So we go up again, 1, 2, 3, and across, 1, 2, 3, 4. Yep, same distance. Y'all see that? 4 and 3. So that means both these lengths are 5. So to find the perimeter, we're going to add all those together. So 5 plus 5 plus 9 plus 9 plus our 8, okay? So obviously that's 10 plus 18 plus 8. Wait, 10 plus 18 is 28 plus 8 is 36, right? So we are at 36 units. However, did you notice what it said here? 1 unit equals 4 feet. So we don't just put the 36 in there. We got to multiply that by 4, okay? So we're going to do 36 times our 4. That's going to tell us how many feet this is. So when we multiply 36 times 4, we get 144. And that's going to be feet, because remember, that's the distance around the outside of the object. That's what perimeter means, okay? All right, so for our next one, it says, a pig pen in the shape of an octagon is shown below. The scale of the drawing is 1 unit equals 3 feet. How many feet of fencing would be needed around the area? Round your answer to the nearest foot. Okay, so let's see if you guys can figure this one out. Come back to me when you're done. All right, so once again, I'm going to look at the things I know. So this goes from -4 to 2, so that's 6. Looks like this one's the same, so both of those are 6 and 6, okay? So then I'm going to do these sides right here. So this looks like it's 1, 2, 3, 4 tall. This one over here is 4 tall as well. All right, so now we're going to use our Pythagorean theorem again to find the length of this side right here, okay? So we're going to go up 3 over 3. So that's 3 and 3, right? So we're going to do 3 squared plus 3 squared. That's going to be equal to 9 plus 9. So that's going to be 18. And remember, we're going to take the square root of that 18, right? So when we do that, I got 4.24. Or we can just leave it the square root of 18, right? Because we're going to add the square root of 4 times the square root of 18. Why? Because this one's 3 tall. Whoops, let me do that back in red. 3 tall by 3 tall, right? Or wide, sorry, 3 by 3. And again, 3 by 3, okay? So we've got 4 of those, you notice? Okay, so what I'm going to do is I'm going to actually take the square root of 18. I'm going to round that number, okay? Take the square root of 18. When I do that, I got 4.24. Obviously, we're going to multiply that times 4 because we have 4 of those, right? So that one is going to be 16.97. Then we're going to add to it our 4 and 4. So that's going to be 8, right? Because 4 plus 4 is 8. Plus our 6 plus 6, which is 12. That's 20 right there, y'all. We're going to add to that the 16.97. So pretty sure that's going to be 36.97. Now, once again, do you notice what it says here? 1 unit equals 3 feet, right? So we're going to multiply the 36.97 times 3, right? Because remember, this is just a length, okay? So we're going to do 36.97 times 3, and when we do that, I got 147.88, and it says round your answer to the nearest foot, so that's going to be 148 feet, okay? It says the vertices of the triangle shown are x, y, and z. What is the area of the triangle? Okay, so remember, area is equal to 1/2 base times height, right? 1/2 base times height. Well, this is our base. And remember, our height is always a right angle to the base. So we're going to go straight up from the base to the peak and create a right angle, okay? So these two actually are pretty easy because we can count them, right? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 wide. And let's count how tall it is. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our base is 10. So we're going to do 1/2 of 10 times our 12. So isn't that going to be 1/2 of 120? Which means this is going to be 60. And it's going to be units, right? That's our area squared, okay? And remember, if we don't have the unit, then we're just going to say unit squared. All right, let's see if you guys can do this one, okay? All right, so once again, it looks to me like our base and our height. So we could call this our base this time, couldn't we? And we could draw our height from here. Okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's 16. What is this one? 1, 2, 4, 5, 6, 7, 8, 9, 10. So this one's 10. So 16, again, 1/2 base times height. So that's 1/2 of 16 times 10. So that's 1/2 of 160, which would be 80. Again, units squared. Okay? Now I want to show you all something because when you guys are doing the delta math, it shows a different way to do this. Okay, so what it does is draw a, go to the furthest point over here and the furthest point there and then the furthest point here. And we're actually going to draw a rectangle around all that, okay? So that's what they did, was drew a rectangle around this. And this works better when things don't line up on the lines, okay? So for this one, for example, we're going to do, this is 10, right? And this was 8. This was 10 and this was 8. So what they're going to do is actually do 8 times 10, that's 80, okay? Let's take that back. We got to do our whole length. Sorry. So we're going to do the whole height here. So that's going to be 16. 16. It'd be great if I could actually get the pen to work. 16 times 10, y'all. That's 160, okay? Now what we're going to subtract from that are those triangles, okay? So again, our base and our height are going to be one of these. If these create right angles, right? So we're going to do 8 times 10. And that's going to give us 80, right? And take half of that. 1/2 base times height, right? So that's going to give us 40. Doing it again with the other side, so that's another 40. So we add those two together, that's 80. Then we would subtract the 80 from the 160, and that would give us 80. And isn't that what we got? Okay, so this is the way that they teach it how to do it on Delta Math. They find a rectangle that basically encompasses the whole space and then create right triangles to get rid of the space that's not included. Okay? All right, so this one says find the area of the triangle with the vertices. Okay, so this kind of looks to me like it's a right triangle, y'all. But there's two ways we could approach this. And this is what I was talking about before. So everybody look up here. So what I'm going to do is I'm going to draw a shape that encompasses the whole thing. And y'all are going to see that we're going to end up with 3 triangles inside there. Do y'all see this right here? So this is the way that Delta Math does this, okay? So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 over here, and that goes from -6 to 6, so this is 12. So 9 times 12, isn't that 108? Okay, so that's 108. So now what we can do is subtract all these other little triangles around here. Okay, so we can do this one, and this would be 1, 2, 3, 4, 5, 6, right? So that's 6. So 9 to half, 1/2, 9 times 6, that's 54. So half of 54 is equal to 27. Okay, that's our black one over here, this one. Okay, then we're going to do the blue one right here, this one. Again, we're going to do 6 times 4. So 1/2 of 6 times 4 is 1/2 of 24. So 24 divided by 2 is equal to 12. Okay. And then this one down here, I'm just going to let it be red, y'all. Whoops, maybe if I can get the red to show up. So this is our red one. If I could draw a straight line, that would be amazing, y'all. So 1, 2, 3, 4, 5 tall and 12 wide. So that's 5 times 12 and half of that, right? That's half of 60. So 60 divided by 2 equals 30. So if we add up these 3 right here, that would be 27 plus 30 is 57 plus 12 would be 69, right? So we're going to subtract 108 minus 69. Okay, so I think that's my answer, 39 units. Okay, so on this one, I want to show you another way to do it, okay? So notice here again that we have this slope was 9 over 6. 9 over 6, which reduces to be what? 3 over 2, right? And then this other slope, we went down for, didn't we? So this would have been -4 over 6, which reduces to be -2/3. What do you notice about these two slopes right here? They're perpendicular, right? So that means there's a right angle right there, okay? Now, we would have had to still do a squared plus b squared here to get the side, though. Okay, so like, for example, this black side right here, to get it, we would have done 9 squared plus 6 squared. That's going to be 81 plus 36. And so, what is that? I got 117. Is that right? Yeah. So this is going to be 117. So this is the square root of 117, okay? And then we're going to find the length of the blue side right here, okay? So again, to find that, we would do 6 squared plus -4 squared, right? So that's going to be 36 plus 16, that's 52. So this is square root. So now we're going to refer to these as our base and our height. Y'all see that? Of our right triangle. Okay, so we're going to do, again, I'm going to do 1/2 my base times my height. So that's going to be equal to 1/2 of our base. We got was the square root of 52, right? Times the square root of 117. Now, if you do that in your calculator, you're going to get, again, 1/2 of 78. So that's going to be our 39. And again, it's going to be units squared, right? Okay? So again, more than one way to do this, you choose. Example 2 says the vertices of the triangle shown are x, y, and z. What is the approximate perimeter? Keyword perimeter. That means we're going to find the distance around the object, right? Okay, so it looks to me like we can count x, z. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So xz equals 10, right? Then we're going to talk about this one right here. Let me do this in a different color. X, y. Again, what are we going to do here? We're going to go up and we're going to go over. We're going to create our right triangle and we're going to find that length of that x, y, right? So I went up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I went over 1, 2, 3, 4, 5. So to find x, y, we're going to do 12 squared plus 5 squared. That's 144 plus 25. That's 169. And then we're going to take the square root of 169, right? So when we do that, we get that this equals 13. Okay? So it looks to me like it's an isosceles triangle, but let's check it just to make sure. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Indeed. And this was 12. 1, 2, 3, 4, 5. So that would be the same, right? So that means this is also going to be 13. So this length right here is 13, and this length right here is 13. And we said the bottom length. So xy and yz. Yz is also 13, right? So we're going to do 10 plus 13 plus 13. Well, 13 plus 13 is 26, plus 10 is 36. And again, this is just units because we don't know what the measurement is. So we got one more for you guys to try. So this is our you try 2. It says the vertices of the triangle are J, K, and L. Gives you the points. What is the approximate, again, perimeter of the triangle? Y'all got to read, okay? So to do this one, again, we could count KL, right? KL, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's 16, okay? To find JK, we're going to go up and over. Remember, we're going to create a right triangle, and we're going to count 1, 2, 3, 4, 5, 6, 7, 8 tall. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 wide, okay? So 8 by 10. So to find JK, we're going to do 8 squared plus 10 squared. That's going to be 64 plus 100. That's going to be 164, and then we're going to take the square root of that, right? The square root of 164 is about 12.81, okay? Then let's do this one over here. Let's see. Looks to me like this one's the same as the other one, but let's double check. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, 10. It is. So that means that both of these, both JK and JL, are going to be approximately 12.81. So we can do 2 times the 12.81 and then add to it the 16, right? So when we do that, I got 41.62. Again, this is units because we don't know what the measurement is. Okay?